In this video, I'll be covering question 4, part D from the 2018 AP Calculus AB free response, no calculator allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see my other solutions, please check out those other videos. Alright, so diving into D here, D kind of switches up. It's almost like you can ignore everything that happened before this. Because what they're doing is they're going to give us the height of the tree in meters, can be modeled by this function g. So we've got a new height function, which is g of x, and that's this equation right here, where x is the diameter of the base of the tree in meters. And then they're telling us when the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. According to this model, they want to know what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall. So bells and whistles should be going off as you come through here, that all of a sudden we're talking about this with respect to time game. And our rate of change back here on the diameter, right, this rate also is on a time system. And so none of our pieces, though, like our height of our tree is talking meters, the diameter of our tree, our x, is talking meters, so all of our variables from this formula here are all talking meters. And then we're talking about rates of change with respect to time. Bells and whistles have to go off at this moment that what you're looking at is what's called a related rates problem. We're going to need to be finding derivatives with respect to time, and time isn't one of our variables in our problem. And so related rates comes up, and when we're talking related rates, that's when we need to do what's called implicit differentiation. Related rates problems are basically a fancy way of saying it's a word problem where the derivative is going to be done using implicit differentiation. So whenever I'm doing an implicit differentiation problem, the first thing I try doing is pulling out all of the data that they've given me from this problem. So I come back through now and it's saying, okay, we've got a tree that is 50 meters tall. So G is how tall the tree is. So they're telling me at that point that G equals 50. Then they're telling me the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. So the diameter, that is my x amount. And how that's changing with respect to time, because it's per year, would be a dx dt value of 0.03. And then from there, the question wants to know what is the rate of change of the height of the tree with respect to time. So what they want me to go find is they want me to go find dg dt. That's what I'm being asked to do right now. Well, that means we need to go find our g equation, and we need to take its derivative with respect to time. So our g equation is right here. So I know g equals 100x over 1 plus x. And what I do with implicit differentiation is I'm going to wrap that in a set of parentheses, and I'm going to ddt this thing. So I come through and I'm going to take the derivatives of these individual pieces. When I'm doing implicit differentiation, I've got a little saying that I use, which is every time I take a derivative, I get extra stuff. And what that extra stuff is going to look like is, envision there being like a little box behind that D on top. I'm going to get this D, and then I'll fill that box in with whatever the letter is I took the derivative of over dt. And we're doing all of this as a dt here, right? Because it's with respect to time. So let's work our way through this using that rule. So taking the derivative of g like you normally would, that would be a 1. I took the derivative of a g, so I get a dg dt. I'm filling that box in with the letter of what I just took the derivative of. Equals, and as I come over here and I need to take the derivative of this thing, remember that chain rule, product rule, quotient rule, all these rules still apply. And so What I see in front of me on this one is the fact that I've got two chunks being divided. And whenever I've got two chunks being divided, that means I need to follow my quotient rule recipe. So my quotient rule recipe goes low, D high, minus high, D low, and all of that is over the low squared. So I label the top piece the high piece, the bottom piece the low piece. And when I say D high, that means the derivative of the high piece. And when I say D low, that means the derivative of the low piece. And it's in those moments when I'm finding those derivatives right there that I am taking my derivative and I am getting my extra stuff out. So what I do is I break them into bite-sized problems. So I know that the high is 100x. I know the low is 1 plus x. So then I need to go find my d high. The derivative of 100x would be 100. I took the derivative of an x, so I get a dx dt. Then I go find my d low. The derivative of 1 would go away. The derivative of x would be 1. Took the derivative of an x, so I get a dx dt. And now I come through and I put everything back together. I call these my ingredients right here. So I put everything back together following my quotient rule recipe. So the quotient rule recipe says first go grab low. So 1 plus x. Multiply that by the d high. So 100 dx dt. Then minus, go grab the high piece, 100x. Multiply that by the d low. I don't really need the 1 there, so I'm just going to call that dx dt. And all of that is over the low squared. So once I've finished up my derivative, now I can see that what I'm looking for, dg dt here, that's this side. Okay, so I've got dg dt equals. And what I want to be able to do is now plug in for all the variables in that formula. Well, I have a dx dt that was given to me, so I can plug in there, but I'm missing an x value. So now you have to pause and say, okay, so how am I going to find that x value? Again, you kind of have to say, like, why did they give me this piece of information? Because I'm not plugging that into this formula here, so what use was it to me? But they definitely wanted me to know that information. They told it to me twice in the problem. Well, remember that your height is equal to this equation here. So we can plug 50 in for our height, set it equal to 100x over 1 plus x, and solve that to get our x. So we would say 50 equals 100x over 1 plus x. And now we'll solve that equation to get x by itself. So first move here is I would multiply both sides by 1 plus x to get that out of the bottom. As I do that, multiplying through here, 50 times 1 would get me 50. 50 times x would get me a plus 50x. And that's going to equal, those two pieces cancel out, so I get 100x. Now I just want to get all my x's together on one side, so I'm going to move the 50x over to this side. We get 50 equals 100x minus 50x is going to get us 50x. And then I would go ahead and divide by 50, divide by 50, and we get out of there x equals 1. So I now have my x value. I've got my x value to plug in. I've got my dx dt to plug in. So now I'm going to start plugging everybody into this formula down below here. So we're going to get dg dt equals, now we're plugging into our equation here. So 1 plus x, which we just got out as 1, times 100 times dx dt, which is 0.03, minus 100 times x, which is 1, times dx dt again, which is 0.03. And all of that is over 1 plus x is 1 squared. So now I want to start working my way through this, figuring out what, just kind of doing some quick multiplication and division and things, right? So when I look at multiplying these things together, remember that 0.03, that's like saying 3% of this number is kind of how I do the math quickly when I'm working with 100 here. Otherwise, you'd have to kind of do this off to the side, or you just, think about it as 3/100ths of 100, however you want to think about it. I say this is 3% of 100 3% of 100 is 3. So then I take 3 times 2, and that's going to get me 6 on top, minus, and again, here I have 3% of 100, so that's going to be 3. On the bottom, I get 1 plus 2 is 2. 2 squared is 4, so that's going to be 4. And so then I get dg dt 6 minus 3 is going to get me 3 over 4. And then the units on this are going to be your g units, which are in meters, over our time units, which are in years. And so what we just found out is that when the tree is 50 meters tall, it is growing at a rate of, the height is changing, I guess its height is changing, is increasing at a rate of 3 over 4 meters per year. And so there's our final answer. So on this problem, there's 3 points. You're going to get 2 points for making it all the way through doing that whole derivative piece right there. So you're going to get 2 points on that, and then they're just going to give you 1 point down here for the answer, for a total of 3 points on this problem. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.